Computers are an important tool for us when designing castings. CAD, or computer aided design, is used by our mechanical engineers and our design engineers to design castings. They have to work hard to make sure they're the right shape and size, and most importantly, that they're not too heavy. The heavier the part used for an aeroplane or a car, the more fuel is going to be required to move it. So there's a lot of emphasis placed on minimising the weight and the amount of metal being used. The designers also carefully choose the metal alloy that they're going to utilise. We have to design a path for the metal to flow into, and our methods technicians and simulation engineers help us do this with special software. They use computers to predict, or we call simulate, the path the metal is going to flow into and that it's all going to work properly. We want to make sure a number of things: that there's going to be enough metal to fill the cast and that there's not too many hard to reach places. We also want to make sure the metal isn't going to solidify before the casting process is complete, as then obviously we'd have to start all over again. The computers and the software help us get all of this right first time. We can use a lot of new technology in casting, and 3D printing is one of these. We make the shape in sand, or the cavity, which is the exact shape as the part we want to make. Hot metal is then poured into this cavity to create the final metal casting. We can now print this mould in sand. This machine prints layers of sand and then a binder to glue those grains of sand together, slowly building up a mould. This is then filled with hot liquid metal, and once that is cooled and solidified, the part can be removed and that sand can actually be reused again. Sand printing is very flexible, and designers love it because it gives them an opportunity to print something, check it and test it through before committing and sending it to the foundry. However, sand printing is a very slow process, so we only use it for a small number of parts. If a customer requires thousands of parts very quickly, sand printing isn't really appropriate for this, but it's still a really useful piece of equipment for us. Plus, technology is always advancing, so I'm sure in the near future we'll be able to make larger parts more quickly. Investment casting has a wide variety of applications, including making medical implants, parts for plane engines and parts for cars. Here we make a special wax shape from our special wax in a wax room. Our design engineer gives us the final part we need, and this is then placed onto a wax tree alongside many other of the same shape. Now, this means that we can make multiple of the same part at once, so it's very cost efficient for us. The wax tree is then coated in a hard shell called a refractory layer, and this is added to layer by layer, each layer given a chance to dry until it is tough enough. This is then heated up gently so that the wax comes free and is then taken and used again for other purposes. This then leaves an empty shell, and we fire it in a hot oven to make sure it is strong enough to be able to withstand the fact it's going to have hot metal poured into it. And this hot metal is going to reach temperatures of 1600 degrees Celsius. The shell is then removed once the casting has solidified and the parts are ready to be taken, to be machined or painted and ready to be sold to a customer. Investment casting brings a lot of possibilities, big or small, and often gives you an opportunity to create really fine detail. You'll find things like art pieces, trophies and sculptures may well have been made in one of our foundries. In our foundry, metal alloys are melted for casting. The metal is put into the furnaces and melted and poured into moulds or casts which our designers and engineers need. Casting is very flexible. We can make parts which weigh several grams up to parts that can weigh several tons. Each foundry will specialise in different areas with different applications. We can melt lots of different metal alloys, including steels, aluminium and zinc, as well as copper and iron. Most of the things which we melt down in our furnaces comes from things which have been thrown away. We're talking aspects of car parts, metal cans and even drinks containers. All these scrap metal pieces are gathered up and used in our furnaces to create new things which we can sell to customers. Our technicians and metallurgists work out exactly what they need to put into the furnace to make sure they're meeting the customer's specifications. They also check the metal to make sure it's clean and to the right temperature. They don't want the metal to solidify before the casting process is done, because otherwise they'll have to start again and create the mould and the cast from scratch. Aluminium has to be heated to 750 degrees in a furnace, and steel has to be heated to 1550 degrees. So we're talking incredibly high temperatures, and the foundry can be a pretty exciting place when metal like that is being cast. Obviously everyone around is given the tools and safety procedures they need to stay safe.